To graph a rational function, you should follow these steps. First, factor the numerator and denominator of r of x. That way you can actually find the domain of the function. Second, after you factor the numerator and denominator, write it in lowest terms. Third, find and plot the intercepts. Use those zeros multiplicity to help. Fourth, find all the asymptotes and graph them, vertical, horizontal, or slant. Next, determine where the graph is above and below the x-axis. Sometimes you have to do this, sometimes you don't. We'll see. And then finally, we're going to draw the graph. So here is our rational function. R of x equals x plus 1 over x times x plus 4. So I can see from looking at this, it's already in factored form. So I'm going to look for the domain of this function. And I see that I have a factored form in the denominator, x equals 0, and x plus 4 equals 0, which is going to give me x equals negative 4. So these are the two values that the function does not exist at. So my domain is going to be from negative infinity to negative 4 union negative 4 to 0 union 0 to infinity. So this will be my domain. So I know it exists in this area here except for at negative 4 and at 0. So now that I know where it exists, next thing I'm going to do is I'm going to try and find the intercepts. So I'm going to let x be 0 first and solve for y. So first things first, I'm going to plug in 0 for all my x's. So I'm going to get y, I'm going to change it from r of x to y, is going to be equal to 0 plus 1 over 0, 0 plus 4. And that's going to end up giving me y equals 1 over 0. Well, I can't have a division by 0, so it's not possible to have a y-intercept. It doesn't cross the y-axis. So now I'm going to let y be 0 and see where it crosses the x-axis. So I'm going to set it equal to 0, so 0 equals. And the nice fact about this is when you set it equal to 0, you only have to worry about the numerator. You can completely disregard the denominator when you set the rational function equal to 0. So x plus 1. Subtract 1 over, we get negative 1. So the graph crosses the x-axis at negative 1. So I can put that right there, fill that in. And now I'm going to look for the asymptotes. So first one is the vertical, which is the work has already been done for you. X equals 0 and x equals negative 4. These are your vertical asymptotes. Since you already did it before to find the domain, no need to do it again. So at x equals 0 and x equals negative 4, we're going to have some, I say imaginary line, but I like to put a line in there just so we can see it. So at negative 4, and at 0. And these red dotted lines, the graph can never cross. Now, I need to find the horizontal asymptote. So I can see that the top degree is going to be a 1. And in the bottom, I can see that x times x is going to be x squared. So the bottom is greater than the top. And when that's the case, you have a horizontal asymptote at y equals 0. So that's a nice easy one. So I can just draw a red dotted line, y equals 0. So pretty darn good. But now I got to find out where the graph is. I only know that it crosses here at negative 1. But what is it doing? It can't cross the horizontal on this side or this side. In this case, it can only cross in the middle. So is it up top, in the bottom, what's going on. So what we're going to do is we're going to find out where the graph exists. So I'm going to zoom out a little bit, and I'm going to pick a value over here. I'm going to say x equals -5. So I'm going to plug -5, forgot the negative, I'm going to plug -5 into the rational function and see what I get. So when I do that, I'm going to get -5 plus 1 over -5 plus 4. And that's going to give me a -4 up top, and that's going to give me a -5 times -1, which is going to be -4 over 5. So it's negative. So this graph exists somewhere in the bottom corner. So at -5 and -4/5, we'll say right there. Now I'm going to do it again. I'm going to pick some value in here that's not the 0, so I'm going to pick -2. I'll write the x a little bit better than that. So I'm going to plug -2 into my function, and I'm going to get -2 plus 1 over -2 times -2 plus 4. And that's going to end up giving me -1 over -2 times 2. And that's going to give me a positive 1/4. So it's positive. So it's somewhere above, right about there. And then last I'm going to choose 1 because it's over here. Is it above the x-axis or below the x-axis? So x equals 1. And I'm going to get 1 plus 1 over 1 times 1 plus 4. And that's going to give me 2. 1 times 5, so 2/5. So it's above. So 2/5 is going to be, we'll say right there. Now, I know everything I can about this graph. So I know that this graph, when I connect all the dots, is going to be in this bottom part here. So it's going to go like that. And since it's above here, this has to start above here because it only crosses once. So it's going to go like that. Maybe not quite like that, but pretty close. And this is going to be above. So this one's going to come down and then go through it, and then it's kind of straddle the horizontal asymptote like that. Now it'll probably be a little bit cleaner when you do it, but that's what this looks like when you take all the information for the rational function and graph it.